correlation. And we're going to determine if there's a relationship between two pieces of data to determine the line of best fit. That's what we're going to be talking about today. Now, correlation is basically when two sets of data appear to be connected in some type of way. In other words, like one affects the other. And there are various methods that we can use to check whether or not there is any correlation. One of the most known methods is, and the one that you're going to be basically dealing with, is a scatter diagram, aka a scatter plot. Okay? Now, a scatter diagram is like any other graph. So you'll have an x and y axis. The independent variable goes on the horizontal axis, and then the dependent variable goes on the vertical axis. Now, when I say independent and dependent, that means that to determine if there is a relationship, then that means that the independent variable is the one that affects the dependent variable. Okay? And so we're going to look at the different types of correlation that you can have. Okay? You can either have positive, negative, or no correlation at all. What do you think positive correlation looks like? It's data that goes up, positive, things like a positive slope. So it's data that looks like it is increasing. Negative would be what? Going down. And what about none?
Neutral.
Neutral is everywhere. Okay, in other words, it's not going up, it's not going down, it's just literally scattered all over the place. Okay? These are three different types of ways to describe a correlation. It can be positive, it can be negative, or it can have no correlation at all. Okay? Now, if it is positive or negative, then you can describe it even more. Okay? Then you can describe it even more. Now, if you have a positive or negative correlation, not none, because if it's none, then you don't, describe it anymore. But if it's positive or negative, then you can either have strong, moderate, weak, or perfect correlation. Okay? Strong, if you notice, all the data is really close together. And it's close together basically centered around like one line. Okay? So say if I were to draw a line through each of the data, right? The closer the data is to the line, like the stronger it is. Okay, so if you look at the strong data, if you see the dots, the circles, okay, the bubbles almost, they're really, really close to this line. That's why they have a strong correlation. The moderate, it's still pretty close, but it's not as close as it would be if it's strong. Okay? Weak, as you see, is a little bit more spread out from that line, and then of course perfect, they actually fall on the line. Now, when you do your scatter plots, if you ever have to draw them yourself, you can see them in different ways. They could be, larger circles. They could be points. A lot of times they're more like X's, okay? And sometimes they might be, squares, empty squares, not just filled-in squares, okay? Lastly, you could have linear correlation or nonlinear. What do you think linear looks like? Like it looks like it's forming a line, right? And nonlinear would be what?
Not a line.
Like a circle or a square, or let's go more functions, less shapes. Like a parabola, like a quadratic, or a
what do you call like a three asymptote? No.
Exponential. You might be thinking rational a little bit. But you have linear versus nonlinear correlation. Now, the line does not need to be there in order for you to determine if that's linear or nonlinear. Again, the line does not need to be there. Okay, like the data is going to curve or, form a line in its own respective way. Okay.
What about that little guy at the bottom of the
Like you're talking about this one right here?
Yeah.
Okay. Now, yes, you can have like maybe one or two pieces of data that don't quite fit the whole line type function. Those just means that they are outliers. Okay. But that still has no effect on the majority of your data that still forms a line. Same thing with this. That's also an outlier as well. But the majority of the data falls almost like an exponential type of correlation. Okay.
So it would actually say maybe like those size 2 that are like perfect.
Exactly. So yeah, like the one that you got that was a size 2, that would be like an example of an outlier. Okay. Questions on describing the different types. Okay, so again, you can represent a box, you can represent a scatter plot with boxes, X's, points. My only thing is if you decide to use points, dots, you make them more noticeable than just a little, okay? Because if there are lines, like a lot of lines, like almost like 1 centimeter paper, I'm gonna need to see that just a little bit better, okay? Everybody understand that? To be honest, I like using X's. It's a lot easier to see. It's more noticeable. Okay. So we're gonna do we're gonna just practice. We're gonna graph some of these scatter plots. The manager of a recreation park just said thought that the number of visitors in the park was dependent on the temperature. Okay. Let's reread that sentence. He thought that the number of visitors was dependent on the temperature. Okay. So right there, you kind of already know what's going to be on your horizontal axis, what's going to be on your vertical axis. Which one's going to be where?
Horizontal temperature.
Horizontal is going to be temperature, and visitors is going to be vertical. Okay? Always make sure that you label your X and Y axis whenever you're graphing. I think I said this before, but I'm going to say it again. Okay? And I went down to the, it says something around the lines of, he recorded the temperatures over a 2-week period. We have to plot these points on the scatter diagram and then comment on the type of correlation. Okay? So if you ever have to graph one yourself, okay, you make the scale, make sure it makes sense. But even if we use different scales, we should be able to determine the same type of comment about the correlation, whether it's positive or negative, whether it's strong, weak, or moderate, whether it's linear, non-linear, if there's no correlation at all. Okay? Yes?
What if it's somebody's like opinion based? Like, say it looks weak, but it looks moderate, so like, it's okay, it's gonna be moderate.
That is a good question. A lot of these, if you have to draw them yourself, and depending on what scale you use, we might have that type of problem. However, if the graph is given to you, then there should be no debate about whether or not it's moderate or if it's strong. After, I don't know if we'll get to it today, but definitely by the next class, you'll be able to figure out algebraically which one it is. So, all right. So, are we making our scale? Are we graphing these points? I shouldn't have to do this. You guys should be able to plot some points. Yes. Okay. So let's do that. We're also making a comment on our data, comment on our correlation, the type of correlation. Is it positive, positive, negative, none? If it is positive or negative, is it strong, moderate, or weak? And then is it linear or non-linear? Okay? So look at this problem. Maybe if your data does not look like mine, that's fine. If you use a different scale, that's fine. But I think we can all agree that was your data positive, negative, or none?
Positive.
It was definitely positive. Mine definitely looks like it's positive. It's going in an upward fashion. Okay, so we agree on that. Can we both agree that our data look linear?
Yes.
That's definitely for sure. And then what else did you say?
Strong.
I would definitely say it's strong. Question?
Yeah. I see. Do we have to start our graph on my y-axis? I started it at 200.
This is the thing, okay? For me, since I did my x-axis, going by, every 2 lines, I did it by tens, and I did start here at 0. This is the same 0 that starts your y-axis. So you can't start here with a 200.
No, I started at the next line with 200, but then it went up by 10 after the 200.
That's fine. Just make sure you add the little break in there. Just tell it to skip the walk.
Like it's like a little zigzag, right?
Yeah, it's like a little.
Do that.
Yeah, that's fine. Just make sure that you don't start 200 right there. Okay. Everyone good? Would you agree? If you're, I know some of y'all probably didn't do the scale that I did, but you should see that your data is going up, is close together to like an imaginary line that we draw through them. Yes?
Yes.
Okay, cool. All right. We got another one. Same thing. Here we go. We got a mathematical studies student wants to check to see the correlation between the predicted height of daisies and their actual heights. We're going to draw the scatter diagram to illustrate the data and comment on the correlation. What do you think we're going to make the horizontal axis? Which one? Predicted, and then the vertical, actual. Just a quick little thing. The way it's listed in the table is usually which one's X and which one's Y. Okay? So go ahead and make your scale, plot your data, comment on your correlation. Is your data plotted? Comment on it. Positive, negative, or no correlation?
Positive.
Positive. And are we going to say it's linear, non-linear? Linear. And what did you say? Was it strong, moderate, or weak?
Moderate.
Okay. Depending on your scale, it really could, it really is kind of like, based off the judgment. Okay. Definitely depending on your scale. For me, I probably would have said that mine was moderate, comparing mine to the last one that I just did. Everything was really, really tight together. This one I would have said moderate. Lee, I would say that yours is moderate. Yes. Now, I would say that yours is moderate. Yours would actually still be considered moderate because if you think about it, if you're thinking, okay, well, is it going to be weak or is it going to be moderate? Draw a line through your data. If your data is still pretty close to that line, maybe it's not right on it, but it's close, then do so. But if your data is sitting somewhere out here, then that's when you say, okay, it's weak. Does that make sense?
Mm-hmm.
Okay, cool. So question on that. All right, I want you guys to flip the page. There's an IB question here. I want you guys to answer them. I'm giving you 2 minutes. It should only take you 2 minutes to do this. And then we're going to check answers.
Oh,
Wait,
no, actually, no.
Yeah.
All right, what you guys say A was?
Two.
Option 2. And 2 said it was a... Very good. Low basically means a weak, okay, a weak positive correlation. correlation. Very good. What you guys say for B going across?
B.
It was option 5 because it was high. It was very strong, but it was going negatively. Okay, what you guys say for C?
3.
Option 3. There is no correlation here. We can't tell if it's positive, negative, or anything. And then D?
1.
1. Very good. Okay? 4 for 4?
Yep.
Good stuff. Okay? Let's keep it moving. Now, the line of best fit is a line that is drawn on a graph of 2 data sets so that it approximately has as many points lying above the line as it does below it. So you know that line that I drew through my green graph? That was my line of best fit. That's how you can kind of tell whether or not your data is weak, strong, or moderate. Okay? So how do you draw this line of best fit? By eye, because of course there's a calculated way to do it a more precise way. But to do it by eye, and I mean eye as in like hand drawing it. You need to find the mean of each set of data and plot this point on your scattered diagram. So you find the mean of your x values, you find the mean of your y values, and then you plot that point. Then you want to draw a line that passes through that point that is close to all the other points. So basically you have an equal number above that line and an equal number below that line. So what we're going to do is we're going to draw the line of best fit for both the last 2 examples that we did, okay? So we're going to flip back to the ones that we drew, our scatter diagrams that we drew. We're going to look at the first one that was talking about the manager, comparing the number of visitors to the temperatures. And we're going to draw the line of best fit. So we need to find the mean of our x values and the mean of our y values. How do you find the mean? Add, count how many there are, and then divide by however many there are, okay? So, as we flip back here, we need to find the mean of the temperatures and the mean of the number of visitors. Do that now. All right, so what's the mean of the temperature?
Hold on.
Thanks.
36 fixed.
Yep. And the number, for the number of visitors?
You forgot.
251.
So we're going to plot this point. This is how you plot the mean point, okay? Of course, you go to 23.3, and I go to 251 on my data, okay? I'm going to draw a dot, a point. I'm going to circle that point, and I'm going to label it with the capital M. That is how you plot the mean. So you, of course, plot the point, you circle the point, and then you label it with the capital M, okay? And then now we're going to draw a line of best fit by eye. So we're basically going to draw a line, okay, that's going to go through the mean, and where about half of our data lies above the line, half of our data lies below the line, okay? And you want to make sure that it hits your y-axis as well, okay?
Yeah.
Like, do we actually draw the line and fix the total?
There's your line of best fit.
130 goes straight to the
Add them all up and divide by how many there were. Okay? I want you to do the second one. Go to the next one, do the same thing. Alright, so here are my means for my x and my y values. So I'm going to plot them. Both of these are really close. Yeah, did a pretty good job. So you plot the point, circle it, label it with the M, and then you're going to draw a line that goes through your data and through your y-axis. Now, depending on your scale might not allow you to go through your y-axis. You go somewhere through your x-axis. That's fine. But it's really just based off of the scale that you used. Okay? So make sure it's a smooth line. And there you go. That's how you draw the line of best fit by eye. Questions on that? Okay. Listen carefully. This is your homework. Okay? Then I'm going to hand out your quiz. Your homework. There are 3 IB exam questions that follow the notes where it says line of best fit. Okay? You're going to answer this question. You're going to answer the second question. You're going to answer the third question. Basically, answer all the questions before you get to Pearson product moment correlation coefficient. Everyone got that? Okay. And also, you are drawing a scatter diagram. for your heights and shoe sizes. Exactly. Now, that is 60, yes, that's 60 pieces of data. I want it on graph paper, and I do